Let us take one more example on Maclaurin's theorem. Apply Maclaurin's theorem to expand f of x equal to sin x. Let f of x be a function of x differentiable n times. Then Maclaurin's series of f of x is given by f of x equal to f of 0 plus x f dash of 0 plus x square upon 2 factorial f double dash of 0 plus x cube upon 3 factorial f triple dash of 0 and so on. Here f of x is equal to sin x. Therefore, f of 0 is sin 0 and sin 0 is nothing but 0. If we differentiate sin x, derivative of sin x is cos x. Therefore, f dash of 0 is cos 0 and cos 0 is equal to 1. If we again differentiate cos x, so derivative of cos x is minus sin x and f dash of 0, f double dash of 0 is minus sin 0, which is again 0. Now f triple dash of 0, derivative of minus sin x is cos x, and since there is a minus sign, so minus cos x, and if we substitute x equal to 0, we are getting minus of cos 0, which is equal to minus 1. If we find out f4 days of x, again derivative of cos x is minus sin x, and this minus and minus will become plus sin x. So again, if we write down, if we put x equal to 0, f4th days of 0 is nothing but sin 0, which is equal to 0. So now if we can differentiate in the same manner, then we are able to find out the each and every derivatives. No need to write down because we have the pattern. Let us see how we are using the pattern over here. So let us substitute all these values in equation number 1. We have f of x is what? F of x is nothing but sin x. So we have written sin x. F0 is 0. F dash of x, f dash of 0 is 1. F double dash of 0 is 0. F cube upon 3 factorial into f triple dash of 0 is minus 1, x to the power 4 upon 4 factorial 0, and so on. So therefore sin x is equal to x minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial minus x to the power 7 upon 7 factorial and so on. Now look here. If we see the expansion of sin x, I think we know about this formula. Most of the time we have used that. What is the value of sine of minus x, which is written as minus of sin x, right? We know that we say that sine function is odd function. Why it is called odd function? Because as per the definition of odd function, if f of minus x is equal to minus of f of x, then for all value of x, then we say that this function is called odd function. Clearly, here, what is the the expansion of sin x? Expansion of sin x is nothing but x minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial minus x to the power 7 upon 7 factorial and so on. So just look here, what is the power of x in each and every term? All powers are in the odd powers, right? So that's why the sine function is also called odd function. This is the expansion of sin x. Let us go ahead to take one more example. If you want to find out the expansion of cosine function, what will happen? In this lecture, we will apply Maclaurin's theorem to expand f of x equal to cos x. Let f of x be a function of x differentiable n times, then Maclaurin's series of f of x is given by f of x equal to f of 0 plus x f dash of 0 plus x square upon 2 factorial f double dash of 0 plus x cube upon 3 factorial f triple dash of 0 and so on. Let us give this as equation number 1. Now our aim is to find out all these values f of 0, f double dash, f dash 0, f double dash 0, f triple dash of 0 and so on. Here, what is value of f of x? F of x is nothing but cos x. So if we put x equal to 0, f of 0 is cos 0 is 1. Now f dash of x, derivative of cos x is minus sin x. F dash of 0 is minus sin 0 and sin 0 is 0. Then f double dash of x, derivative of sin x is cos x and minus sin as it is. So minus cos x, which is equal to minus of cos 0, which is minus 1. Again, if we differentiate f triple dash of x, so derivative of cos x is minus sin x and minus minus will become plus sin x. So derivative of minus cos x is sin x. So f triple dash of 0 is nothing but sin 0, which is equal to 0. F fourth dash of x, which is again derivative of sin x is cos x. So we are getting f double dash of f fourth dash of 0, which is cos 0, which is equal to 1. Now, similarly, we are able to find out the derivative of each and every term, but no need to find out. We got the what are the pattern we are getting. So putting our values in equation number 1, we have f of x equal to cos x, f0 is 1, f dash 0 is 0, f double dash of 0 is minus 1, f triple dash 0 is 0, f 4 days of 0 is 1, and so on. So if we substitute all this value, we are getting cosine x is equal to 1 minus x square upon 2 factorial plus x to the power 4 upon 4 factorial minus x to the power 6 upon 6 factorial plus x to the power 8 upon 8 factorial and so on. So now clearly this is the expansion of cosine function. If we see the pattern of cosine function, again we know about, again we are going to define what is the meaning of even function. What is even function? Even function is nothing but if f of minus x is equal to f of x for all values of x, then such type of function is called even function. And most of the time we use this formula. What is the value of cosine of minus theta? It is cosine theta. Clearly, so cosine theta is even function. And how we are able to get over that, how we are able to prove that cosine function is even function? Just look here. What is the degree of each and every term in the given expansion of cosine function? It is 2, 4. 1 means what? We can write down x to the power 0, x to the power 2, 4, 6, 8, 10, 12, and so on. So in each and every term of the expansion of cosine function, we are getting the even powers of x. So therefore, cosine function is called even function. So in this lecture, we have discussed about the expansion of sine function and cosine function, and we also observe that why sine function is odd function and cosine function is even function. Thank you.